Harvard's CS249r Machine Learning Systems course, the kind of curriculum that costs $200,000 in proximity to access, has been completely open-sourced on GitHub by Professor Vijay Janapa Reddi. This isn't a watered-down summary or a teaser. It's the full architecture: data pipelines, production systems, MLOps, edge AI, and privacy-preserving compute. All of it free. But before you retweet this as a revolution in education, let's talk honestly about what that actually means. Most ML courses end where the real work begins. They teach you to train a model in a Jupyter notebook and call it machine learning. CS249r goes further, covering edge deployment, on-device inference constraints, privacy-preserving computation, and the operational reality of keeping a model alive in a production environment. These are the topics that senior engineers quietly struggle with because nobody taught them systematically. This curriculum fills a gap that has quietly cost companies months of engineering time and thousands of dollars in avoidable mistakes. The hype cycle around free elite education tends to imagine a scrappy beginner transforming their career overnight. The reality is more nuanced. Experienced engineers already working in ML will extract the most immediate value, using this as a structured reference to fill specific gaps. I've worked alongside senior engineers who had never seriously considered on-device inference constraints until a product requirement forced a crisis. A structured curriculum like this could have compressed months of painful discovery into weeks of deliberate study. There is a specific kind of suffering that happens at 2 a.m. when a training pipeline breaks in production, and you have never personally owned that failure before. No curriculum prepares you for that moment. Only having lived through it does. Reading about MLOps gives you vocabulary. Debugging a corrupted data pipeline under pressure gives you instinct. The uncomfortable truth is that open sourcing elite education removes one barrier: access, while leaving the harder barriers completely intact. Feedback loops, real stakes, and problems that actually matter to someone. If you're going to pick one pillar from this curriculum to go deep on, edge AI is the right choice for this moment in the industry. The demand for on-device intelligence is accelerating across consumer hardware, industrial sensors, and medical devices. The practical exercise is simple and revealing. Take a quantized model, run it on local hardware, and carefully measure latency, memory footprint, and thermal behavior under sustained load. What surprises you in that process is more educational than reading 6 chapters about it. Write those surprises down. They become your actual knowledge. There is a comforting but misleading narrative that information scarcity is the primary obstacle between talented people and elite outcomes. Open sourcing a Harvard curriculum challenges that assumption productively, but it doesn't erase it. Motivation sustains itself when there are consequences, deadlines, and people depending on you. Feedback loops require someone more experienced to tell you when your mental model is wrong. Real problems provide the resistance that turns knowledge into skill. A GitHub repo delivers none of those things. It is necessary infrastructure, not a complete solution. The worst way to use this resource is to read all of it and feel educated. The best way is to pick a single pillar, go deep enough to build something real, even something small, and document what you actually learn in the process. Feeling educated and being capable are two completely different internal states, and the gap between them is where most self-directed learning quietly collapses. The curriculum is here at mlsysbook.ai, and the full repo is on GitHub under Harvard-Edge. It is genuinely worth your time. Just be honest with yourself about what you're going to do with it. The ML Systems field rewards people who have shipped things over people who have read things. This curriculum gives you a rare structured map of a domain that most practitioners learned chaotically and incompletely. Use the map to navigate towards something you can actually build and measure. Run that quantized model, break the pipeline intentionally, measure thermal throttling at sustained inference load. Write down what surprised you, because surprise is the signal that your mental model just updated, and that is the only thing that actually counts as learning.